Okay, everybody, this is Dr. G, and it is time for more operations management secret sauce. Okay, here we go, guys. Today we're going to talk about probabilistic activity time estimates in project management. This isn't super complicated, but it seems like something that we need to go over one more time just based on how students have done in the past, which isn't as well as they could have done. All right, so let's say we've got an activity in a project, right? So typically we represent that maybe with a circle on an activity node on node diagram, and the most likely time for that activity is 12. Let's say that means 12 days. Okay, it doesn't really matter. All right, so we got a most likely estimate, and we got a pessimistic estimate and an optimistic estimate. Okay, and you can see those are 14 and 10. So then the question is, what's the expected activity time? Okay, and you probably look at this and say, well, the most likely time is 12, so the expected time should be 12. And in this case, you would actually be correct because the distribution is symmetrical. Remember, we use a triangular distribution to estimate these activity times, and 12 is the midpoint. We got 14 here and 10 here, so it's completely symmetric, right? So just as much chance of being 10 as there is of 14, just as much probability of being, say, 10 and a half as 13 and a half, so the expected time there is going to be 12. We could use our formula, which is the pessimistic time plus 6 times the most likely time, that's 4 times the most likely time plus the optimistic time divided by 6, all right? And if you add those up, so that would be 14 plus 10 plus 4 times 12, you'd see that's 72, divide that by 6, and we get 12, okay? So why do all this math and stuff? Because, you know, we all hate math, right? Why not just go with that to begin with? Well, the reason for that is this distribution, it kind of looks like a normal distribution, but the difference is this distribution is not always symmetric, right? Here it's symmetric, but it might look something more like a pessimistic time of, say, 20. All right, so in that case, we'd have 12, 10, and then 20, right? So the distribution would look something like that. Okay, and that, if you think about projects, I don't know about the projects you guys have been involved in, but a lot of times in projects, when activities go wrong, when things go wrong, they go really wrong, right? So, plus you're always bounded on 0 down here, and effectively there's no bound out here on this side. You know, we've got infinity out here on this side, right? So this is maybe a little bit more realistic scenario for a lot of activities within projects. So, you know, now the average is not going to be 12 anymore. Okay, so this is when we really need to use this formula. So we just take the pessimistic time of 20 plus 4 times 12 plus the optimistic time of 10, and now we divide that by 6, and that, I know just by looking at it, that's going to be more than 12, right? Because I've got this stuff out here that I've got to deal with. I guess we can do the math on this real quick just for kicks. So that's 48 plus 10 plus 20. So that'd be 78 in the numerator, right? Divide that by 6. You guys can do the math on that. It's going to be more than 12 though, right? It's going to be 12 point something, okay? So that's how we get the most likely time. Now we have this idea of what's the variance. Okay, so this is now 20, 10, 14, and we figured out, I don't know, what's 70? Let's just say it's I don't 12 point something. Okay, so what's the variance, right? Because if we're dealing with probabilistic times, we got to have some sense of, you know, what the likelihood that it's going to wind up being the expected time. The greater the variance, the less the likelihood it's going to turn out to be the expected time every time. Okay, so we got to figure out the variance. So the formula for the variance, a little symbol for the variance, that's just the square root of the standard deviation, right? Sigma squared. It's just the difference between the optimistic and the pessimistic time squared divided by 6. Okay, so let's just do that real quick. So let's see. So the pessimistic is 20. It doesn't really matter which order you do these in because you're going to square them. The optimistic is 10. So that'd be 10 over 6 squared. So I'm not sure what 10 over 6 is. Let me do the math on that real quick on my computer here. That's what my computer looks like. Equals 10 divided by 6. So that is 1.667. And then if I square that, let's see. I'll just, 2.777, or maybe call it 2.8. Okay, and remember I can take that 2.8 now and I can convert that to standard deviations and I can start to work with you know, probabilities. But the key for today is just getting the expected time and the variance around that expected time. And remember, anytime that you have a non-symmetrical distribution like we have here, you're going to need to use the formula to get the expected time. If the distribution is completely symmetrical, like we talked about, it doesn't matter if you use the formula or not, your expected time is going to be the same thing as your most likely time. And that's what we've got to say about probability activity times in projects.